And now for part 2, where we're going to work through some examples of graphing linear inequalities. Remember, the procedure has 2 steps. Step 1, draw the boundary line. That is, draw the graph of the equation. And when you draw that line, if you have a less than or equal to or a greater than or equal to in your inequality, make it a solid line. If it's just less than or just greater than, make it a dashed or dotted line. That's to show that in that case, we don't want to include the points that are actually on the line itself. And then step 2, figure out which side of the line the inequality is true on and shade everything on that side of the line. The test point method involves picking any point that's not on the line, and the origin is often an easy point to work with. Plug its coordinates into the inequality, and if the result is true, shade the side that includes the test point. If not, shade the other side that doesn't include the test point. An alternative method, if your inequality is solved for y, if it has y by itself on one side, if it has y greater than the stuff on the other side, you want to be above the boundary line. If it says y is less than or equal to the stuff on the other side of the inequality, shade what is below the boundary line. Okay, now some examples. X plus 3y is less than 6. Step 1 is to graph the line where x plus 3y is equal to 6. If I use the intercepts method, when x is 0, 3y equals 6, so y equals 2. That gives me the point 0, 2. If y is 0, x equals 6. That gives me the point 6, 0. And then I can draw the line through those 2 points, but I draw it as a dotted line because of the less than. I don't want to include really the points where x plus 3y is equal to 6. So since the points on the line are not included, I show that by making it a dotted line. Step 2, test a point that's not on the line. So I'm going to try 0, 0. Plug in 0 for x and 0 for y, and it says 0 plus 3 times 0 is less than 6. Well, that's true. So we do want to be on the side of the line that includes the origin, the point 0, 0. So that would be below the line. So I go ahead and shade that in, and that is my solution. That's the graph of that inequality. Next example, y is less than or equal to 3x minus 5. So the first step would be to graph the equation y equals 3x minus 5. And since that's set up in slope-intercept form, the slope of that line would be 3, and the y-intercept would be negative 5. The easiest way to draw the line might be to start at negative 5 on the y-axis, and then have rise over run be up 3 and over 1 to get the direction for the line. Now this time I draw the line as a solid line because we are including the points on the line. It does say y is less than or equal to 3x minus 5. Then, now here, since this is solved for y, it says y is less than or equal to 3x minus 5. I can say we want to be below the line. The further down you go, the smaller the y coordinates get. So if we want our y coordinates to be less than what they are on the line, we're looking at points below the line. So shade everything below that line. If we had used the test point method, if we test the point 0, 0, it's going to say 0 is less than or equal to 3 times 0 minus 5. In other words, 0 is less than or equal to -5. That's not true. That's false. So we do not want to include the point 0, 0. We want to be on the other side of the line that doesn't include 0, 0. Next example, y greater than or equal to 2x. The line where y is equal to 2x has a slope of 2 and a y-intercept of 0. So it crosses the y-axis here at 0, and then rise over run, go up 2 and over 1, and there's the line. I made it a solid line because of the greater than or equal to. And then for y to be greater than or equal to 2x, we want to include the points that are above the line. Now, this is an example of where if we use the test point method, it would not work to use the point 0, 0, because that's on the line. That wouldn't tell us which side of the line we want to be on. Whoops. But we could pick a different point, like say 0, 6, where x is 0 and y is 6. Then we would have 6 is greater than or equal to 2 times 0. That's true. So we do want to be on the side of the line that includes 0, 6. Any other point would work as long as it's not on the line, as long as we can tell one side or the other where it is. X is less than or equal to 3. The line where x equals 3 is this vertical line. Remember, when you just have x equal to a constant like 3, you get a line that just goes straight up and down, and all the points on that line have their x coordinate equal to 3. And then if we want to shade where x is less than or equal to 3, that would be everything on this side, everything to the left of the line. All the points where x is 2 or 1 or -7 get included. Y is greater than -1. So to start with, the boundary line is where y is equal to -1, and that would be this horizontal line. All the points on this line going right straight across have their y coordinates equal to -1. And then for y to be greater than -1, we want to be above that line. And remember, we didn't include where y was equal to. It's strictly greater than, so I made it a dotted line and then shaded above the line. Now, sometimes you'll have more than one inequality at the same time. You'll have a system of inequalities, and we want to know where all of them are true. So we graph each one separately, and then we just take the region that they have in common. We look at where they overlap. So here's an example of a system of two inequalities. X plus 2y is less than or equal to 10, and 5x plus 3y is less than or equal to 30. What I'm showing now is where x plus 2y is less than or equal to 10. The solid blue line would be the graph of the equation where x plus 2y is equal to 10, and then everything on this side of the line, like including 0, 0, would be where x plus 2y is less than or equal to 10. Then for the second inequality, 5x plus 3y is less than or equal to 30, the boundary line where 5x plus 3y equals 30 is this solid green line, and then shade the side of that line that includes the point 0, 0. And now we look for where these overlap. So the final solution here is this region down here, below the blue line and below the green line, the part that's down here where these overlap. Now you can do these on paper, or there's a way to do them online. So I'm going to show you how you could do something like this online if you wanted to submit your homework online. You will have to go to the website desmos.com/calculator. And I do have a link to this on Canvas, or you can just type it in, desmos.com/calculator. /calculator. So this brings up a graphing calculator that you can do online. And now I'm just going to type in the inequalities that we were working with. So one of them was x plus 2y is less than or equal to 10. Sorry. And I can type that in on the keyboard, or I can use sort of the built-in keyboard that goes with the software. So I can type in x plus 2y is less than or equal to 10. And there it shows me the graph. Let me zoom out a little, or zoom back in. There we go. And now I'm just going to click right below that, have room to put in another one. Let's see, what was the other one? 5x plus 3y is less than or equal to 30. So 5x plus 3y is less than or equal to 30 looks like that. So there's my graph. Let me zoom in a little. So the region here where these overlap is the solution set to the system of inequalities. Now, once you have this, if you want to submit this as your homework, you could either use your phone to take a picture of the computer screen, or if you're signed in, you can make an account or sign in with Google. It will let you save what you have here, and then you could just copy the URL, and if you give me that, I should be able to go in and look at what you have, I think. I don't know, I haven't tried this, but you can try that and see how it works. There's also a version of this Desmos graphing calculator that you can get as an app for your phone. So you could do it on your phone and somehow send me what it looks like on the screen of your phone if you can figure out how to do that. So anyway, that's how to graph inequalities and systems of inequalities in two variables.